All right, hi guys, my name is Megan Hulser and I will be talking about chapter 23, specifically reactions of amines. So we're going to start with the simple question as to what are amines? All right, so the first thing we're going to look at is their structure. So there actually is primary, secondary, and tertiary amines, just like with halides and things like that. So first, I'm going to show a primary amine. So this primary amine is characterized by one R group. So an example of this would be methylamine. So, and it has two hydrogens instead of more than that or less. The second one, oops, I forgot to write. This one is primary. A secondary amine looks like this. With these two lone pairs. And this has the two R groups. And an example of this would be dimethylamine. All right, and then a tertiary amine, you probably already know what it's going to look like by now. Oops, we're going to make these R's instead. Oh, I can't get my pen, sorry. R, R1, R2, and R3. There's the two lone pairs. It's a tertiary amine, and it has three R groups. Right there, and right there. And an example of that would be triethylamine. All right, so there's those. And then a second thing that's important to understand when we're talking about amines is the difference between an imine and an enamine. So the imine is going to be a double bond to the nitrogen and a single bond on the other side. All right, so that's an enamine. And then, that's an imine. Excuse me. An enamine is going to be a nitrogen with two double bonds, but or two single bonds, but there's a double bond next to it. So this one's going to be an enamine. All right, so there's those. The next thing that we're going to talk about is primary amine reactions with carbonyls. So let me write that. Primary amine reactions with carbonyls. Right? Okay, so like the main, I'm not going to go through the mechanism for these ones just because we talked about this a couple chapters back, and this isn't technically chapter 23, but is instead kind of just a review so we can get on the same page. So I'm going to write out just like the basic reaction for this. So that is going to be a primary amine because there's two hydrogen groups, one R group. And then, sorry, no arrow yet. We're going to add it to this molecule, which is an aldehyde. And then out of this reaction, we are going to get H2O. And our final product is going to be this, which from our last slide, we know that this is an imine because of that double bond and the single bond connected to the nitrogen. And then let's see, the next part is going to be talking about a secondary amine reaction with carbonyls. And again, I'm just going to go through the basics. I'm gonna make this fast by copying this. So there's a hydrogen there. That is a tertiary amine. There's a hydrogen there. We are going to react that with this, and then out of this reaction, we are again going to get H2O and this final product which is, from our last part, we know that this is an enamine because there's a single bond on this side and then a single bond and a double bond on this side. So we can see that right there. So basically, the important part that we need to take out from this is we are reacting an amine with a secondary amine plus a carbonyl. We are going to get an enamine. And if we're going to react a primary amine with a carbonyl, we are going to get an imine, not two I's. All right, so this is an important thing to remember. One reaction that we can go over with amines is the quaternization of amines, sorry. And then I'm just going to go over the basics with this one again. So it's going to be nitrogen like that, plus R and halogen. And from quaternization of amines, we actually get this molecule. Cool. So as you can see, this nitrogen, it now has 4 groups on the final product. There's going to be an R group, as well as it is now connected to the halogen. So it's taken both of the things that we reacted it with. Okay, and then another important reaction with amines is the Hofmann rearrangement. So we're going to go over this one pretty in depth. All right, and basically the description of the Hofmann rearrangement is that it is a synthesis of amines from amides. So if we're going to look at the general reaction for the Hofmann rearrangement, we're going to see a molecule like this. This is just going to be our example with the primary amine. We're going to react it with the base of NaOH and the halide of Br2, as well as H2O, and we're going to add heat in there. And with this, we are going to get the final product of, this product and CO2. So that's the basic reaction. And we're going to make this a little bit smaller because we're actually going to go over the mechanism. Just because it's an important mechanism. Because when you first look at this, it's kind of interesting how you think you get this, but we're going to go over it. Mechanism. All right, so we start with our compound like that. So there's that. And then we're going to react it with the OH, the base from that NaOH, it's a negative. And the first thing that's going to happen is this is going to attack this hydrogen, which is then going to kick off onto this. So there's that. And from this, we will get this molecule we're still going to have this double bonded oxygen. There's that. The next part is we are going to react this with the halogen, which this negative charge is going to go after the bromine. So it's going to attack this, which is going to kick off that. And now that bromine is going to be added to the nitrogen, like that. You'll still have a lone pair. And then this one should actually have a lone pair too. All right, so we see that makes sense. And then the next part is we are again going to react it with this hydroxide ion, OH. And as OH usually does, is it attacks this hydrogen, which then kicks up there. And then from this, we get this product. Nitrogen is back to having 2 lone pairs and a negative charge. We still have this oxygen. But then this lone pair is actually going to kick onto this single bond, which is going to kick up there for the oxygen, which in this oxygen should have 2 lone pairs. And we will get pretty much the same thing, but instead now we are going to have a double bond here. Like that. All right, from here, bromine is going to kick up. The R is going to actually attack nitrogen. And this is going to fold down, so we'll get another double bond there. And this is going to make quite an interesting product. So we're going to have O, the double bond to C, the double bond to N, a single bond to an R group. That should not have a double bond. This one will have our lone pair, like that. We're actually going to react this with the water that we made in the previous step. So this oxygen lone pair will actually go attack this carbon. Double bond will attack the N. This double bond will attack the O, and this lone pair will attack here. That's what that's going to look like. And we're kind of running out of room here. So we'll end up getting, I'm going to go up here a little bit. N, C, O. Now the O is going to, or the OH is, sorry, the H2O is now connected. Now the nitrogen is going to attack the hydrogen, which is going to kick up there, giving us our final product. Of this. That's our final product for Hoffman rearrangement. Perfect. Okay, one last thing that we're going to talk about for this video is the courteous rearrangement. And that happens, so we're going to start with this molecule again. So we're going to have a chlorine there. We'll react it with NaN2. There'll be a nitrogen there. So that's what'll happen when you react those. And then one last final step. So we add some heat on there. And we get this final product. And that's it for that one too. All right, that's all I have today about reactions of amines. So thank you.